Hey guys, welcome back to my YouTube channel, which I haven't uploaded on in forever. Today we're going to be attempting leetcode problem 6-7 at binary. And so besides the fact that it's like 6-7 is a funny number, binary addition is a topic that we've been going over in my computer architecture class. And so I think that I get the concept behind this, and I think I could solve this easy question without any help. Or like, at least like, it says it's easy, but I don't know if it will be, because I don't know if I've ever solved a leetcode problem first try, but that's what I'm going for here. So yeah, I haven't solved this yet. This is like my regular account that I never use, but yeah. So let's read the instructions here. Given two binary strings A and B, return the sum as a binary string. So I can kind of see already that if it's going to be a string, we're going to have to turn them into integers for each bit, add each bit, turn it back into a character, and then append that to our string result. So for example, if we have a string of binary 1, 1, which is 3, and binary 1, which is 1. 3 plus 1 is 4. That should give us 4. So 1 times 2 to the power 2 is 4, plus 0 times 2 to the power 1, plus 0 times 2 to the power 0, so 4 plus 0 plus 0, that's 4. That is correct, so yeah. I think the thing that worries me for these is that some of the inputs may have different bits, different number of bits, so we're going to have to kind of account for that. And I think what I'm going to do is start off by padding those smaller numbers with 0. In binary, what that does is basically nothing, but it just increases the number of bits. So 1 and 0, 1 is the same thing. Alright, so let's try this. We need the if the length of A is less than the length of B. We're going to have to keep continually adding those zeros onto our A string. So again, while that is less than the length of B, we're going to have to add the 0 character into the front of our A string. Same thing with if B dot length is less than A dot length. While that is true, B, while that is true, keep adding those zeros onto B. That should be right. And then, we're going to need a string which holds our result. And for now, it could just be an empty space, kind of like assigning a variable, like an integer variable, 0 or null. Actually, we're going to have to do that for our next one. We need a carry variable. We'll make that 0 for now, because in binary, what happens is if your sum exceeds 1, there isn't a symbol for that, so you're going to have to carry that over to the next place. So, for example, 1 plus 1 is 2 in decimal, but in binary that wouldn't work. It would be 1, 0, because you would have to first apply the modulus operator, place that into your current spot, and then carry over a 1. So right now, that's 0. And then let's do the length of A minus 1. So A length, no, let's just do I. Equals A dot length minus 1. So why I'm subtracting 1 from this is because in C++, strings, so our A string would be an array of characters. But if we want the correct index, we're going to have to subtract 1. And same thing for, let's just name it J, the index of B. So that's a pretty common trick from like intro to programming that most people learn. I think we could set up our loop now, use a while loop. Because what I'm thinking is, as long as I is greater than 0, or J is greater than 0, or carry is not 0, so as long as there's digits in I or J, or their carry isn't 0, we could keep adding stuff. And then we'll have to have a sum that equals basically the value of A at index I plus B at index J plus carry. However, the problem is the value of A at index I is a character because these are strings, and so is the value of B at J. Carry is the only integer, so I think what I'm going to do is I'm going to have to convert those into integers first. So if I is greater than or equal to 0, something has to happen. If J is greater than or equal to 0, something happens, and then we're going to have to decrement I, right? So that this doesn't go on forever. So every time you add it to the sum, it's going to have to subtract from I. And then so what I'm thinking is we're going to have to do sum equals sum plus A. Actually, we could just do it like this. AI. But AI is a character right now, so what we're going to have to do is subtract our 0 character to convert it into its integer value. That's a pretty common trick from ASCII conversions, and then we could also do that for B at J and subtract the 0 character from it, and then that should be good for the inside of these if statements. And then our carry would have to be our sum of these digits over 2, because that's what we're going to carry. And then from that, we're also going to have to apply the modulus operator. So what happens is basically what goes into your place is the modulus of the sum of those digits with 2. So basically what I'm trying to say is if our sum is 3, we can't just put 3 in that digit. We're gonna have to modulo that with 2. So 3 mod 2 is 1. We would have to put 1 into that digit. And yeah. And then I think we're done. We just have to append it to our result, the front of our result. So that would just be sum. Turn it back into a character by typecasting it. Add our result to it. And then we could exit the loop and return our result. So this is my first try. I haven't tried it before. This is my account. I barely ever go on it, but I think this is right. Let's see. Let's just submit it then. Yeah, I'm kind of scared. Oh shoot. Oh shoot, spelling mistake. That can't happen in an interview. Okay, yeah, so the time complexity is pretty trash, but I guess we solved it. Dang, so many solutions are more efficient. But it should be O of 1, no? Oh, yeah. I don't know, I don't think it's gonna get much better than that. Maybe if we don't append the 0, it might be faster. I don't know, because I feel like this one was unnecessary. I didn't really get the problem. But if we just have I and J, it shouldn't matter. Let's see if that's any faster. Yeah, it's a little bit faster, but still not that fast. Well, that wraps up our video, and I'll probably never upload again, but thank you for watching. Bye.